Okay.
Alright, so on this one, the domain. We'll talk about domain, we'll talk about the range, we'll talk about the increasing, decreasing, constant, and whether or not it's continuous. Okay, now like I said, our domain is our x values. You agree this arrow goes all the way to the left, and it's going all the way to the right. So our domain's all real numbers. Range is what our graph is doing, bottom to top. So my graph starts right here. What's the y value at this point?
0.
0, and it goes all the way up to infinity. So my range is from 0 to infinity. Now let's look at increasing, decreasing, and constant. First of all, is it constant anywhere? Do you see a horizontal line anywhere? No, so it's not horizontal, not constant. Alright, let's do increasing and decreasing. If I'm starting from negative infinity, starting at the leftmost point of my graph, what is my pencil doing as I go down toward the origin? Decreasing. So it's decreasing from negative infinity to 0. Let's use a bracket on that 0 since it's included in part of my graph. Starting at 0, it starts going what? Up, which means you are increasing. So it would be increasing from 0 to infinity. Is this graph continuous? The whole time I trace it, would I ever have to lift up my pen? No, so it's continuous everywhere. Now notice, all these properties for the absolute values and the quadratic are exactly the same. Domain, range, increasing, decreasing, continuous, everything's exactly the same for both of these. Alright, next we're going to talk about the square root function. On the square root function, you've got y equal the square root of x. Okay. Well, anytime you have a square root function, where you can only take the square root of positive numbers and get a real number answer. Do you agree? If you took the square root of negative 4, you'd get 2i, which is complex. Now, this is a real number line and a real number line. So we're graphing real numbers. So a square root function would always start here at the origin, because what's the square root of 0? 0. And then you can take the square root of everything else. It's going to kind of gradually go up. This is what every square root graph looks like. Has this basic shape. Because we have the square root of 0 is 0. The square root of 1 is 1. So I have the point 0, 0, the point 1, 1. Over here at 4, the square root of 4 is 2. So I have the point 4, 2, and so forth, right? Now let's talk about domain, range, increasing, decreasing, constant, and we'll talk about if it's continuous. Alright, so looking at the domain, what's my leftmost x value here? 0, and it goes all the way to the right, which would be to infinity, right? So it's going to be, 0's included, I can take the square root of 0, so my domain is from 0 to infinity. My range is what my graph is doing bottom to top. What's my bottom y value here? 0, and then this s is going up, but it's going up slowly, but it continually goes up. So my range is also from 0 to infinity. If you're only taking the square root of positive numbers, you're only going to get positive answers. And you agree 0 to infinity, that's positive numbers, right? Let's do increasing, decreasing, constant. If I put my pen on it and if I start tracing it, what am I doing? I'm going up. So that means it's increasing everywhere. So it's increasing from 0 to infinity. It never goes downhill, so decreasing is none, constant's none. Do you agree over the entire domain I never have to lift up my pen? So it's continuous from 0 to infinity over the whole domain. Alright, next we're going to look at our cube and cube root function. These are our squiggly. So for our cube function,
Are they two separate?
yes,
You agree?
we have y equal x cubed. my cube function, it always will have this basic shape. Now I'm going to show you the cube root function. I'm going to talk about the difference in them because everybody tends to want to mix these up. Okay. So look at these two functions. One's a vertical squiggly, one's more horizontal. The cube function is more stretched out, the cube root kind of compact. But think of what your answers are if you started plugging in here. On this first one, let's say if you did one of your little T-charts here, if I put in 2 for the x, what's 2 cubed? 2 cubed is 8. What's 3 if I cube it? 3 cubed is 27. 4 cubed would be 64. So you see, even though you got your y's is going to be stretched out. You got 2, 8. Then you're going to jump up to 327. It's going to be a long, tall graph. Do you agree? Because when you cube a number, you get a bigger answer than what you started with, right? So it's going to be a stretched out answer. Over here, if it was the cube root graph, if I put in 8 for my x, what's the cube root of 8? 2. Cube root of 27 is 3. So out here at 8, you finally get up to 2 at 3. And when you get to 27, you're just barely getting up to 3. So you see this graph is flat. It's complex. It's going to get long going horizontally, but your answers, your y values are always going to be something small. So when you take a cube root graph, you think that's my short, squishy graph. And a cube graph, I get big answers, so it's stretched out. Okay? Does that help you a little bit there? All right, let's look at domain, range, increasing, decreasing, and constant. Continuous. Domain, range, increasing, decreasing, constant, and then we'll talk about it as continuous. All right, domain. This arrow is going to go down, but it's also, as it goes down, it's going all the way to the left. This arrow, as it goes up, is gradually going all the way to the right. So my domain is all real numbers. You can put in any real number for x and cube it and get a real number answer. Range, all the way to the bottom. This one's going all the way to the top. So my range is all real numbers. Now, increasing and decreasing. Start tracing. Leftmost point on the graph here. If I trace it, what's your pen doing the whole way? It's going up. So that means it's increasing everywhere. It's not decreasing at all. There wasn't horizontal anywhere. Okay? Is this graph continuous?
Yeah.
Right, so it's continuous over the entire domain from all real numbers. Like I said, your base 6 of your basic graphs are all continuous. I'm just going to see one in a few minutes that's not. Let's do the same thing here. Talk about domain, range, increasing, decreasing, constant, and continuous. All right, domain. All the way to the left, all the way to the right. You agree? My domain is all real numbers. Range. This there, as it goes further to the left, gradually it's going all the way down. This there, as it goes up, gradually goes to the right, gradually goes all the way up. So my domain on both of them and range is all real numbers. Let's decide if it's increasing, decreasing, or constant. If I start to trace it, I'm gradually doing what? The whole way. You're gradually increasing the whole way. So it's increasing everywhere. So you're not decreasing, you're not constant anywhere. Did I ever have to lift up my pen? No, so it's continuous everywhere. Okay? Everybody good? That's your 6th basic graph. Now for the 7th, which your book calls the reciprocal function, but I call it the rational function. When you hear the word rational, what goes through your mind? A fraction, yeah. So for a rational function, when you have, say, y equals 1 over x, what do you have to keep in mind anytime you have a fraction? That you you can never divide by what?
Zero.
0. So on any rational function, you've got an x in the denominator, so you've got to remember x can never be equal to 0. I want you to give me a second to catch up with me, and then we're going to think about something else too. Okay, so we're good that x can never be 0. What about my answer? Is there any number I can put in for x that would make this whole thing equal 0? Can this 1 ever be turned into a 0? No. So x can never be 0, but your answer, y, will never be 0 here either. You agree? Because if you're on all of these problems that you're going to have at this point, you're always going to have a constant number in the top. And if there's a constant number in the numerator, it can never be 0. So on this one, x can't be 0, and y is not ever going to be 0. Y will be 1, y can be -1, but it can never be 0. So when you go to graph this function, it looks like this. It gets real close to these axes, but it never actually touches either one of them. It never touches the x-axis, never touches the y-axis. Okay? The reason it never touches the x-axis is because if it's on the x-axis, x would be 0. We just said. I'm sorry, y would be 0. Y'all caught up with me? If it crossed the x-axis, you agree, anywhere it crosses the x-axis, y is 0. We just said y can never be 0. And also, if it was an x was 0, that's the vertical line of the y-axis. Any point on the y-axis has an x value of 0. So it never cross. These are actually called asymptotes. It will never cross either axis because neither one of them can be turned into 0. All right. Now let's look at our domain, and this is going to be your least favorite one. Our domain range, increasing, decreasing, and constant. That was camera again. Okay. Now, like I said on this graph here, these lines here gets real close, say here to 0, but it never touches. It hugs it. It gets right up next to it. It'll be, say, over here, x can be, 0.00001. Or x could be -0.001. It gets right up next to 0, but 0 is never included. Because I could put in here 1 divided by I could put in here 1 divided by like 1,000,000 and get some little bitty number. Okay? So it'll get real close, but it'll never include those numbers. So if I'm looking at my domain, your domain is what it's doing from left to right. So here in my graph, this arrow is going all the way to -infinity, right? And this graph gets real close to 0, but it never includes 0. I'm going to say it's going to get close to 0, but 0 is not included. So what do you think I'm going to use here since 0 is not included? Right, you're going to use a parentheses, and you're going to use that union because your graph is in 2 parts. Now right here, my graph picks back up real close to 0, but 0 is not included, so I have to use a parentheses. And then it goes all the way to the right, which is to +infinity. Okay? Range is what my graph is doing, bottom to top. Well, this arrow goes all the way to the bottom to -infinity, and it gets here, and it gets real close to where y is 0, but once again, 0 is not included. So I put in parentheses, put the union, because here my graph picks up real close to 0, but doesn't include it, and it goes all the way up. Okay? This will be your worst one. All right, increasing and decreasing. Let's start at my leftmost part of my graph, right here on the left. If I trace this, what's my pen doing?
Down.
It's going down. So that means it's decreasing from -infinity to 0. Well, starting back up here at 0, what's it doing still here? If I start tracing?
Decrease.
Still decreasing. So this one's decreasing over the whole, over your entire domain. So it's decreasing everywhere. It was not increasing anywhere. It's not constant anywhere. Would you say this graph is continuous?
Yes.
Wouldn't it be?
No. Do what now? No.
Hold on. I got some no's, it's what? It's not continuous.
Because they're not together.
Because, yeah, I mean, if I can draw this part, and then I gotta pick my pen up before I can draw this part.
Right.
So continuous, the answer is no. And if it asks you for the interval, it would be the same interval here as your domain. Because you still got it broken up at 0. Now, on my actual test I'll give you, not necessarily what will be in my math lab, but if I ask you on continuous, I'm going to ask you for yes or no. Okay? So that's my basic graphs. So now when you start to graph them, you're going to have a basic idea. And I got 5 minutes, so don't pack up. We're jumping back to section 2.1. So let's go back to 2.1, and we're going to have a general idea of how we're going to graph some equations. Back in 2.1, we are graphing. Okay, and we're going to talk about one of the main ways that we're going to do our graphing. We're going to talk about graphing using a T-chart, which is kind of like what I've showed you up here. On the T-chart, typically you will plug in at least 3 values for X and find Y. Okay. You can also graph using intercepts. Remember your x-intercept, you find by letting y equal 0. So this will always be some point. Remember, it's the x-intercept, it's the point that crosses the x-axis. The y is 0. So you'll have some number for the x, y is 0. Your y-intercept, you will find by letting x equal 0. Solving for y. So you'll always have 0 for your x, some number for the y. Alright, so let's look at some examples here that we're going to graph. Okay, first of all, let's say we want to graph 2x plus 3y equals 6. Well, let's think about those basic graphs. Here, both x and y is to the first power. So what kind of graph is it? It's linear, which means it'll be a line, right? Well, if I was going to graph this line, you could stop, get y on the side by itself. You could do the T-chart. Or it's a lot of times easier, it's in this form, instead of doing a T-chart, to find these x and y intercepts. Well, if I want to find my x-intercept, I just told you, you find it by letting y equal 0, right? So put a 0 in place of the y and solve for x. So that's when 2x is equal to 6. Divide both sides by 2. So it's when x is 3. So my x-intercept is the point 3, 0. My y-intercept, we find by letting x equal 0. So that would be 2 times 0 plus 3y equals 6. Or when 3y is 6, divide both sides by 3. So you get when y is 2. Now to graph them, you can plot you can always play connect the dots. If you have 2 points, you can connect them and you'll have a line. So we've got my x-intercept, which is at 3, and the y-intercept is at 2. So plot your 2 points. The plot 0, 3 would be, the plot 3, 0 would be to the right 3. The plot 0, 2 would be up 2. Connect your 2 points, and you have the graph of that line. Okay? Stay with me for just a second. I'm going to show you one with a T-chart. We'll do a square root graph. Second one, let's say if we have y equal the square root of x plus 2. Alright, this is the way I want you to think through this. We're not going to make this real hard. We're going to make it easy because I know the basic shape. What's the basic shape of a square root graph?
Cube.
Kind of looks like that, right? A square root one?
Okay.
Okay. Well, wherever this endpoint what made it 0, right?
Right.
Well, what number if I put in place of this x would make this underneath here 0?
-2.
-2. So what this graph is going to be is you're going to come over to the -2, and then you just draw your basic shape. Not hard, and it's easier because you know the basic shapes. So you know it's going to look like this. Whatever number makes it 0, that's where your graph starts. Okay? Let me show you one more. It's going to be just as quick, and then we're done. Okay, let's say if I have number 3. Y is equal to the absolute value of x plus 2. Well, what's the absolute value graph look like? Absolute value was a V shape, right? Well, that V was, the point of that V was at what made it 0, right? Well, what number I put in here would make this one 0? -2. So let's just scoot that thing over here to the -2 and draw my V. I'm not going to make you give exact points. I just want to make sure you know what this basic graph would look like and you can make it work. Okay? All right, let me give you your homework. All right, it's basically here.